Hello, this is going to be a prime factoring challenge for Algebra 1 and pre-algebra. And the first thing I'm going to do is just remember that a prime number is an integer that has only two factors, one in itself. And we're going to use the word divisibility. Divisibility is the capability of a number to be divided into factors that are multiplied together. If a number is composite, then it is divisible by some number or numbers other than 1. So this is how we're going to do the prime factoring challenge. Take a lined sheet of paper and fold it lengthwise, hot dog style, down the center. Number down the red line of the sheet from 2 to 40, but when you reach the bottom line on the paper, jump to the middle and continuing numbering to 40 down the fold that you just made. So you'll have 2 through 40 numbered on the paper. When time starts, for each of the numbers 2 through 40, either write P if it is a prime number, or else write the product in its prime number form. Okay? Then you're going to record how long it takes you to finish, and then check for mistakes, and then repeat if you need to. Okay, so let's talk about a quick lesson about prime factoring. Divisibility by 2's makes every even number greater than 2 a composite number, and that hopefully makes sense. So 10 is 2 times 5, 22 is 2 times 11, and 28 is 2 times 14 if you divide 2 into the 28, but you have to finish for prime factoring, so 28 is 2 times 2 times 7. The higher the number goes, the more chances you will have to write a composite number which has to then be factored into its own primes. And that's the reason that these 2 through 20 are so important. All right, now divisibility rules. If divisibility by 2's and 5's are done by looking at the ones place, if the number ends at a 5 or a 0, you probably already know that then it can be, then it has a factor of 5. If it ends in an even number, then it has a factor of 2. And if it ends in a 0, it has a factor of both 2 times 5 or 10. All right, so 10 is 2 times 5. 30 is 3 times 10, so it's 2 times 3 times 5, which is also 6 times 5. 45, you may know, is 9 times 5, but you still have to finish to make it prime factoring, so 45 is equal to 3 times 3 times 5. I hope that makes sense. So divisibility by 3's and 9's you may not have been taught before, but you get those by doing a sum of the digits. Like for the 45, 4 plus 5 is 9. If the sum of the digits has a total that's in the 3 times table, then there's a factor of 3. If the sum is in the 9 times table, then there's a factor of 9 or 3 times 3. Okay, so let's look at some examples. All right, the first one we're going to look at is 39. When we look at the 9, there are no 2's or 5's. And so when we add the 3 and 9, we get 12. 12 is in the 3 times table, so there's at least one 3. And when you divide 39 by 3, you get 1, 3, 13. And you should know that 13 is not in the 2's, 3's, or 5's. And so therefore, 39 is 3 times 13, and that is the prime factoring. Okay, now look at 26. All right, 26 has a 2, but no 5's because of the 6. All right, the sum is 8, so there are no 3's or 9's. And so when we divide 2 into 26, we get 13. So 2 times 13 is the prime factoring for 26. All right, now, next number, 111. 111, when you look at the last one, there are no 2's and 5's because of that. And so when you sum the digits, you get 3. So there is 1 3 in the factoring for 111. So divide 3 into 11 goes 3 times with 2 left over. That makes 21. 3 goes into 21 7 times. So 111 becomes 3 times 37. All right, and because 37 has no other 3's in it, the sum is 10. It is prime, and we have the prime factors of the composite form of 111 to be 3 times 37. Right now, next number is 135. There are no 2's because of the 5, but there is at least one 5 there. All right, the sum of 1 plus 3 plus 5 is 9. That means there are 2 3's in there also. So I'm going to choose to divide by 9 and say 135 divided by 9. 9 goes into the 13 one time, 4 left over. 9 goes into 45 5 times. Right, so initially the factoring will be 9 times 15, but you should recognize both of those composite numbers can be simplified. All right, and so you're going to have 3 times 3 times 3 times 5, which is 3 to the third power times 5. All right, now next one. All right, there's at least one 2 because of the 2 here. There are no 5's. When you add these two numbers together, you get a 3. Because the sum is, so you get a 6, so that there's at least one 3. All right, when you divide 3 into 42, you're going to get 14, and you should recognize 14 as a composite number also. So if it is 3 times 14, then because 14 is 2 times 7, we have the factors of 42 is 2 times 3 times 7, and you may already know that 6 times 7 is 42. Right? Now, let's look at 96. 96 has a 2, but no 5. When we sum those two digits, we get 15, so that means there's 1 3, but no 5's. Remember that. All right, when we divide 6, which is the 2 and the 3, into 96, 6 goes into the 9 one time, 3 left over, 6 goes into 36 6 times. So we have 96 is 6 times 16, but that's 4 times 4. All right, and if you'll notice now, then this can be broken down into 5 2's. There's a 1 2 with the 6. There's 2 with that 4 and 2 with the second 4. So it's a total of 5 2's and a 3. And so the prime factoring of 96 is 2 to the 5th times 3. Okay, now let's look at how prime factoring would work if you were doing the challenge. All right, first of all, when we start, 2 is prime because it cannot be broken down into anything but 2 times 1. 3 is prime for the same reason. I think everybody in the world knows that 4 is 2 times 2. 5 is a prime. You should know 6 is 2 times 3. 7 is a prime. 8 becomes the first really tricky number because 8 is 2 times 4, but 4 is not prime. And so therefore you have to change it to 2 times 2 times 2, or you could say 2 to the third. 9 you should recognize. That prime factoring is 3 times 3. 10 is 2 times 5. 11 cannot be factored, so it is prime number. 12, when you start with either 4 times 3 or 2 times 6, you have to break that extra composite number down, and you'll have 2 times 2 times 3. 13 is prime. 14, you should know, 2 times 7. 15, most people know, 3 times 5. 16 is another tricky one. 16 is 4 times 4, but each 4 is 2 times 2. And so how many 2's do we have altogether? We have 4, so that's 2 to the 4th power. 17 is prime. 18, most of you know as 2 times 9, right? But 9 is not prime, and so it becomes 2 times 3 times 3, or 2 times 3 to the 2nd power. All right, now we're going to get to the other numbers. All right, 20. Most of you should know 20 as 4 times 5. However, that's 2 to the 2nd power times 5 when it's prime factored. 21, 3 times 7, pretty straightforward if you know your times tables. 22, same thing, 2 times 11. 23 is not in the 2s, not in the 3s, not in the 5s, so it turns out to be prime. All right, 24 is 4 times 6 is one of them. If you'll notice, each of those numbers is composite, so we end up with 2 to the third times 3. 25, hopefully you know, is 5 times 5. 26, you know that there's a 2 in it. When you divide it, you get 2 into 2, 1, 2 into 6, 3, so it's 2 times 13. 27 is in the 3 times tables, 3 times 9. All right, but if you notice, the 9 is not prime, so we have to make a total of 3 to the third power. 28 is in the 2s. All right, it's also in the 4s. 4 times 7 is 28, 2 to the second times 7. 29 is not in the 2s, not in the 3s, not in the 5s, nor is it in the 7s, so it's prime. 30 is 6 times 5, but 6 is not prime, so it's 2 times 3 times 5. 31, not in the 2s, not in the 3s, not in the 5s, not in the 7s, it's prime. 32 is really tough. It's 4 times 8. There's 2 2s in the 4. There's 3 2s in the 8, so that becomes 2 to the 5th. 33 is an easy one, hopefully. 3 times 11. 34 has a 2 in it. When you add the 3 and the 4 together, you have 7. So this is 2 times something. It's 2 times 17. All right, 35 is in the 5 times tables. When you add them together, you have 8, so there's no 3, so it's 5 times 7. And 36 is one of those. There's a lot of ways to get that one. I see 6 times 6 is 36. There's 2 2s and 2 3s because it's also 4 times 9. And so that is 2 to the second times 2 to the third. All right, so those are the values. As an example, I would like you to try to be able to do the entire 40 in less than 3 minutes. All right, if you can do that, it's going to serve you very well. Thank you, and I hope that you have an enjoyment while you do this.